Okay, welcome to another free online GCSE Maths lesson. Today we're going to be looking at comparing data in Boxplots. It's Mr. Smart here again with you, and we're just trying to make it relevant and real, trying to bring that maths so that it's actually more relevant. And today we're going to be particularly relevant because it's something that affects us all. We're going to be focusing again on screen time, and we're all spending a lot of time in front of screens at the moment, particularly in fact we're all in lockdown. So just to say though, even though we're going to be doing a lot of technology stuff, you still need a pen, pencil, paper, calculator. If you've got any graph paper or squared paper nearby, that would be particularly useful for today's session, and that would be it would just help you out with the box plots, which is what we'll get to in the end. All right, by the end of today's session. So, how does it work? Well, most of you that have joined us before will already know how it works. Anything in blue is for you to have a go at. So, if I said work out the modal interval or modal class from the table below, you know, that's in blue. That's what I'm asking you to do. That's an instruction, effectively. Anything written in purple or with a purple background is something a little bit harder or something a bit different. And in today's session, there'll be a lot of thinking going on. And I'll be asking you questions where I'm asking you to think about why you might be doing something or why it might be useful for someone to collect this type of information. And finally, anything with yellow box with answer on top of it is a solution box. And underneath it will be a solution to something. And just to prove it, there you go, there's the first one. Modal class is 181 to 240 minutes. And the reason for that is that in the frequency column, 7 is the biggest number, and that 7 is 7 people are screen time of 181 to 240 minutes. So the modal class is 181 to 240 minutes. Okay, I want you to have a think though about these two questions. So the first one is, how much time do you spend in front of a screen on a daily basis, so every day? And by screen, I'm not including TV in that. I mean, I'm thinking phone, laptop, desktop type computers. So computers and phones basically is what I'm asking for. So just to define that. And how could you compare pre-lockdown screen time with post-lockdown screen time? So how's that changed? And how could you measure that change between pre-lockdown and post-lockdown? So what maths could you use that you know already that could help you with that? Okay, just take a minute and have a think about that for me. Okay, I think it's interesting because if it was me and I was looking to try to compare two sets of data, one pre-lockdown, one post-lockdown in this case, I'd probably look at a lot of the averages. So by that, what I mean is mean, median, the quartiles, the interquartile range, and these types of bits of information. They can uncover trends or they can uncover patterns in what's going on. And that's exactly what we're going to do in today's session. Yes, we're going to do some calculations, but it's really more about what we do with those calculations and who might want to do those calculations and why might they be doing them. And we're going to start off with comparing pre and post lockdown screen time data by working out an estimate for the mean. Now it has to be an estimate for the mean, okay folks, it has to be an estimate, and the reason it has to be an estimate is because we have intervals. So for instance 0 to 60, and I just want to quickly go over this. 0 to 60, there's 4 people that spend somewhere between 0 to 60 minutes in front of a screen. Okay, now that might not be, that might not seem that common because you think, well, most people spend way more time on the screen than that. But not everyone has access to screens in the same way as some of you do. Not everyone has a smartphone, believe it or not. So there are reasons why that might be lower than you expect it to be. But either way, some people are just very disciplined. They don't spend as much time on their phone as others. But 4 people between 0 to 60 minutes screen time per day. There could be someone that spends 0 minutes there, and there could be someone that spends 60 minutes. The point is, we don't know exactly the amount of screen time they spend per day. All we know is that there are 4 people that spend somewhere between 0 and 60 minutes per day. So because we don't have the exact values, what we do is we take the midpoint, so halfway between 0 and 60, which in this case is 30, and we multiply it by the frequency. Now that's not going to be the exact values, okay? But it's an estimate, and that's why it's an estimate of the mean, not the actual exact value of the mean. All right, so 30 times 4, we do the midpoint times the frequency, gives me 120, and you can see that's what's in this final column here. And I do the same row by row. So 61 to 120 is my interval. The midpoint is 90.5. The frequency was 3. So I do 90.5 multiplied by 3 to give 271.5. And you can see here, I'm doing that for each row. I'm getting each value here, each row. I'm doing the same calculation. And of course, what do we do with these values? Well, if you've forgotten, if you haven't done estimate for a mean for a while, which some of you won't have done, okay, here on the right hand side, a little bit to help you. Sum of fx, that's basically that symbol there, that sigma means sum of fx, and that means we add all of these values together. 120, add 271.5, add 752.5. Adding all these values together, okay, I get 6,373. So that's that bit dealt with. The n underneath is the sum of the frequency, and that's equal to 30. And then I divide them by each other. So 6,373 divided by 30 gives me 212.4 minutes to 1 decimal place. And that's an estimate of the mean before the lockdown. So you can guess where this is going to go. What am I going to ask you to do? I'm going to ask you to calculate an estimate of the mean for the post-lockdown survey. You can see I've clearly, that's in blue there inside that phone image. And if you've forgotten any of the information from I have left it on here to help remind you. The mean of group data is sum of fx over n, and here are what each of those letters mean. So x bar is the mean, f is the frequency of each class, x is the midpoint or mid-interval value of each class, n is the total frequency, and the sum of fx is the sum of the products of mid-interval values and their corresponding frequencies. Okay, so I'm going to ask you to have a go at that. Before you do that though, in your mind, make a decision now. Do you expect the mean to increase or decrease? So do you expect the mean screen time to go up or go down because of lockdown? And if you do expect it to go up or down, in your mind, how much? Roughly where do you think it will be? I want you to start thinking about why you're calculating this data. What do you expect to happen? You might not, what actually happens and what you expect to happen might not be the same thing, but I want you to think in a way where you know why you're doing it. So do you expect the screen time to go up or down when you calculate an estimate for the mean? I'll give you 5 minutes to do that, and it will take a while because, you know, it's quite a few calculations to do. Off you go, folks. Okay, just another 30 seconds or so, and then I'm going to go through solutions to this one. And like I said, I realise there's quite a lot of calculations going on there, so it's quite a lot of actual legwork to do before you actually get to anything. But it's a good skill to go over, so it's good revision as well. And if I just forward on one slide here, you can see I've put solution boxes over everything, and I'm just going to go through them systematically so you can mark your work as you go. And if you have made an arithmetic or calculation error anywhere, you'll just be able to see where it is. So 30 times 0 is 0. 90.5 multiplied by 2 is 181. 150.5 times 4 is 602. 210.5 multiplied by 5 is equal to 1052.5. 270.5 multiplied by 6 is equal to 1623. 330.5 times 6 is 1983. 390.5 times 2 is 781. 450.2 times 2 is 901. 510.5 times 2 is 1021. 570.5 multiplied by 1 is 570.5. And when you sum them, when you add up all of those values, you get 8,715. Okay, I'll put that answer box to one side. And you can see that it's the same class that's been asked for their screen time data post-lockdown, so the answer for the sum of the frequency is still 30. Okay, and to work out our estimate of the mean, in this case, after lockdown, would be 8,715, which is this value here, divided by 30, which is this value here, and I'm sure you all knew that, but just in case you haven't done it for a while. And if you round that to one decimal place, you'll get 290.5 minutes. So the next thing is, you've calculated your pre-lockdown estimate of the mean, and now you've calculated your post-lockdown estimate of the mean. How much do they differ by? And did it go up? Did it go down? What did you expect to happen? I expect most of you thought it would go up, and it has. Okay. The mean pre-lockdown was 212.4 minutes, and the mean post-lockdown was 290.5 minutes. So you can see significant increase, about just under 80 minutes increase, and that's significant. Okay, because in that 80 minutes, that's a lot more time in front of a screen. That could affect your sleep. It affects the amount of data you'd be downloading. There's all sorts of things. To be honest, though, I'm surprised that the mean post-lockdown isn't even bigger than that, isn't even higher than that. And I would have expected it to go up perhaps more. So it wasn't quite right where I thought it would be. I thought maybe it would go up 2.5, 3 hours, because in my case, personally, I think I'm spending maybe 3-4 hours more time in front of a screen working than I did pre-lockdown, where I'd actually meet people face to face rather than meet them online. Anyway, moving on. So we're going to link this knowledge together. That's the estimate of the mean. We're going to keep that. We're going to use that information again later. And just to refresh your memory from the last session, I'm not going to go over cumulative frequency, but we did get some estimates, and this is the same data. We did get some estimates for our median, lower quartile and upper quartile pre-lockdown. And they were done here by going along half of 30, we went along at 15, then we went down and we got an estimate of the median of 200 minutes, which is here, you can see, and then lower quartile, 7.5, and we went down and we got an estimate of the lower quartile is 125 minutes, which you can see there, and the upper quartile, 22.5, we went along here, 22.5 went down, and yeah, 275. And you can see those estimates of the median, lower quartile and upper quartile, that's where we've got them from. We haven't just magicked them up from thin air. That's where we've got them from. And likewise, we did the same thing for after lockdown, and we got an estimate of the median of 280 minutes, an estimate of the lower quartile of 200 minutes, and an estimate of the upper quartile of 360 minutes. So that information we had from last session, I'm using that information plus the estimate of the mean, and I'm going to summarise them in the next slide here. Okay, so have a quick look at those. Okay, probably tells you something already. You're probably looking at it and thinking, looks like people are using their screen or spending a lot more time in front of a screen after lockdown than before lockdown. And I think the information supports that. Okay, but we need to just look at some other things as well before we can really come to any real firm conclusion. And it's not just about whether we're right about how much time people spend. Who wants to know this? Why is it useful information? Why on earth are we calculating it? Okay, well, that's what we're going to talk about in this sort of next 5 minutes or so. First things first, though, I have put an extra calculation in it, and the extra calculation that I've put in is the interquartile range, which you can see here. And that's the upper quartile subtract the lower quartile. In this case, it's 275 subtract 125, which gives me 150 minutes. So the interquartile range before lockdown was 150 minutes. I'm going to ask you to calculate the interquartile range for after lockdown. And if you've forgotten, just to say there's a little reminder there of what the interquartile range is. It's upper quartile subtract lower quartile. And then I want you to look at the next two sentences and answer them. Okay? You are an analyst for a broadband company. Give 3 reasons why you might be interested in the above statistics. So if you was a broadband company, why would you be interested in the above information? Give me 3 reasons why you think it might be useful. And second part, what does the change in the interquartile range between pre and post lockdown actually tell you? Okay? Or does it tell you anything? I don't know. You tell me. But I'll give you a couple of minutes to think about, say 3 minutes to think about that. You need to actually really come up with, think about why. Be creative. Think about it. Okay? If you start using loads more data on your phone, perhaps you need to go onto a different tariff and things like that. Have a think about it. 3 reasons why you might be interested if you was an analyst for a broadband company. Okay, so just to say, the interquartile range, which I've put here, was 360 subtract 200, which is 160 minutes for after lockdown, and it was 150 minutes before lockdown. Interesting. So we'll come back to that, and we'll be revisiting that throughout the rest of this session as well, because it's interesting how when you look at things at face value, they don't always tell you the full story, and we'll come back to that. But you are an analyst for a broadband company. Why might you be interested in the above statistics? And we said about 3 reasons. And one of the main reasons is the data shows that there is an increase in usage of data after lockdown. Well, if people are spending more time in front of a screen, they're going to be using more data. So I think that's a reasonable conclusion to come to. But there's a few other things as well that I would like to say that aren't so obvious. Okay, of course, if people are using more data, potentially that means that the mobile phone companies and the broadband companies could make more money. Of course it does. But also they need to see if their system can actually stand up to the demands. And what I mean by that is that some of you probably have had your systems, your broadband drop off on you, your connection's not been great. It certainly happened to me. I live in the countryside now, even though I'm a South London boy originally, and my connection down here hasn't been great. It's been better than I expected in some ways, to be honest, but it hasn't been great. There has been the odd time where it's caused me problems and I've lost internet connection in meetings and stuff. Not every day, but once every 3 weeks or so I've had problems. But so that's an interesting thing that you might need to know in terms of making sure that your system can handle it. So that would be useful for a broadband company or a mobile phone company from that perspective. But also further questions you might want to ask. Does everyone use data at the same time of day? Is data usage heavier during the day than it is late at night, for instance? I don't know, because lots of people might be streaming a movie late at night or online gaming. I don't know, but I tell you something, if I was an analyst for a broadband company, I'd want to know when the peaks in demand are for data so that I can make sure the system can handle it. So there's all sorts of questions that this would be useful for, but the ultimate one I think is that the more data people use, potentially the more profit the broadband company can make. So there's some good reasons there that we've just discussed. And then finally, talking about the interquartile range, what does the change in the interquartile range between pre and post lockdown tell you? It shows that the interquartile range has gone up slightly from 150 minutes pre-lockdown to 160 minutes post-lockdown. That doesn't tell you the full story. That's an accurate statement based on the calculation, but it doesn't tell you the full story. And I want you to think about why that might not have told you the whole story. And I will answer this again in more depth in a follow-on slide, because we're going to keep working through. So moving on. I don't want to just look at tables. I want to be able to visually look at this quite quickly. So how do we construct a box plot? I'm focused here on the before lockdown or pre-lockdown data. Okay, and you can see here I've actually given you the values. All right, I've given you the lowest value, the median, the lower quartile, the upper quartile, and the highest value. Talking about the lowest and highest values, there's another conversation to be had there, but we won't have time to go into more depth in this particular session. Hopefully in a future session we will. And we've got 0 is the lowest value, and you can see I've literally put that there. It's already on, but just so you can see, highest value is 540. You can see that's there. Upper quartile is here. Okay, median is here, and the lower quartile is here. And that's the pre-lockdown data. And you can see how I've joined that. I've done it neatly, and I've very, very clearly labelled it. The scale is down the bottom, and it's in the same screen time per day in minutes. And you can see I've clearly stated that. Well, it's actually a little bit cut off by the bottom of the page, but you can hopefully, if I just move, I don't really want to move it too much, but screen time per day in minutes. The axis is down the bottom there. Okay, and then moving forward, what am I asking you to do? Well, I'm asking you to construct the box plot for the post-lockdown data. And then this is the key thing, and this is what students fall down on in the test. I want you to write 3 statements about what your box plots tell you. Put your box plots next to each other on the same scale if you can. Even if you just sketch them out. If you don't have squared paper or graph paper, fine. But you should still be able to sketch them enough to get an idea of what's going on. Those 3 statements are what I'm really interested in. Okay? That's where the analysis starts to really happen. I'll give you, say, 4 minutes or so. Good luck, folks. 4 minutes, and then I'll tune back in and we'll go through it. Okay, folks, just put this there. There's the post-lockdown box plot, so they're next to each other. And of course, if you're thinking about it from an exam question point of view, we're looking for the key things to be correctly put onto the scales. Okay, and you've got your lowest value, your highest value, your upper quartile, your median, and your lower quartile. And actually, just looking there, I must say, it looks like that actually should be there. Looks like I've misread the scales when I put this together. So just to say, it just shows you it's easy to make mistakes. And I've looked at these slides how many ever times before I've done it, and there you go. Just a little error there. So I'll just correct that now and put that on. Okay, so there you go. I've made a mistake, and that it happens. So you need to always double check. So you got 0 is your lowest value, which you can see here. Maybe I should do this in red. Just checking my answers. 280 is the median. That's looking good. That's accurate there. 200 minutes for the lower quartile. 360 for the upper quartile, and the highest value. Yeah, I thought that was on 600. I've misread the scales. That should be there at 600. Okay, but there we go. It's in the right place now. And this allows me visually now to make some really quick decisions and judgments on these two sets of data. And I'm looking at it and I'm thinking, this whole box here, what does this bit, the box part, actually represent? Well, it's the interquartile range, which is something you calculated earlier, and I said I was going to come back to it, and I meant it. Okay, now you know the interquartile range here. Okay, you calculated it earlier. Okay, you know it's upper quartile subtract lower quartile. You know the interquartile range is 160 minutes, and that fits because if you look here, 200, 360, the gap between them is 160 minutes. And you knew that the pre-lockdown interquartile range was 150 minutes. And if you look at the gap between the lower quartile and the upper, but look how much that box for post-lockdown has moved to the right-hand side. Okay, look at the gap between the lower quartiles and the medians and the upper quartiles. The whole box has moved a long way to the right-hand side. And the fact that it has, what does that show us? Well, it supports the idea that people are spending a lot more time in front of the screens. So what statements could you have come up with? You can see what's happened, but if you've just gone and looked at the interquartile range, isolated, without looking at it visually in this way, you might have missed something important out. Okay, I'm now going to look at some statements that you may have found useful. Okay, and first statement, the median for the post-lockdown is 280 minutes, which is greater than the upper quartile of pre-lockdown, which is 275 minutes. There, I'm literally looking at the median here for post-lockdown and comparing it to the pre-lockdown upper quartile. Okay, so that means, think about what this means. The interquartile range is the middle 50% of the data. Okay, so you can see it's shifted along to the right-hand side. Also, look here, the lower quartile is, for the post-lockdown, is the same as the median for the pre-lockdown. So 25% of the data post-lockdown is between the lowest value and the lower quartile, whereas 50% of the data is between the lowest value and the median here. So you can see it's shifted to the right-hand side, and this is really good stuff now. This is telling us, supporting what we're trying to say. And the interquartile range spans from 200 minutes to 360 minutes for post-lockdown, which is higher than the interquartile range of pre-lockdown of 125 minutes to 275 minutes. So you can see that, okay? And what I'm making here is I'm making the point how much the interquartile range has moved to the right. That's the point I'm making. And the median usage has increased from 200 to 280 minutes. And other statements you could have come up with. The lower quartile of the post-lockdown is the same as the median for the pre-lockdown. I mean, that's a very powerful, that basically means 25% of the data has moved above the median for the pre-lockdown. So it's supportive of lots more screen time, people spending lots more time in front of the screen. Okay, have a look at these exam questions quickly for me. Spend 2 or 3 minutes on this one. Just be careful, okay, It's not difficult, this one, but you don't get given the upper quartile. You will need to work that one out with the information given. Off you go. Okay, so I'm sure most of you have got quite a long way through this. We'll go through it though, and the only piece of information that you actually really had to work out was the upper quartile. And what I did is I've just put it up here just so you can see. We know that the upper quartile subtract the lower quartile, it gives us the interquartile range. And although we don't know the upper quartile, we do know that the lower quartile is 32, which you can see I've substituted in here. And we know that the interquartile range is 38, which I've put here. I've rearranged then to work out my upper quartile. The inverse of subtracting 32 is to add 32. So 38 add 32 gives me an upper quartile of 70. And that's what we've got there. So that's where the upper quartile has come from. And you can see I've put that on at 70. The highest value was 86. And you can see I've put that on now. Median 57, and that's kind of harder, a little bit harder to do. 52. It should be sort of more. Try to get this. Sometimes the graphics is hard on this especially when you're doing it on a tablet, but it's there. And then the lower quartile is 32, and the lowest value was 18. And you can see I've put those on and joined them up neatly using a ruler, and that would have been a 3. And that's a box standard box plot question, quite an easy one really. Okay, but it's more about the analysis. Okay, that's where students tend to fall down. The actual process of constructing a box plot isn't really that difficult if you have the information. So this one here isn't particularly difficult. Again, there is a bit of construction, but then you have to use that information to make some statements for the second part. So we haven't got that long left, folks, but if you could spend 3 or 4 minutes having a go at this one, that would be great, and then I will go through it in depth before we finish off today's session. Cheers. Okay folks, don't forget when you're doing part B, try to come up with more than one reason. Try to come up with at least two reasons, or two comparisons between the times people waited at Rose's Garden Centre and the distribution of the times that people waited at Green's Garden Centre. Don't just do one, come up with a few. Okay, I'm going to just show the box plot, the lower quartile, the median and the upper quartile. I'll just go through those quickly because I am conscious of time. And you can see here that I've calculated the median to be 25. For those of you wondering how I've done that, you could have done 15 add 1 divided by 2, which would give you the 8th value. And that's how a lot of people deal with this. So first value, second value, third value, fourth, fifth, sixth, seventh, eighth. So that is definitely my median. So my median was 25. Okay, and you can see I've put that on the box plot there. Okay, the highest value was 44, which I've put here. The lowest value was 5, which I've put here. And then I need to work out my lower quartile. My upper quartile, 15 add 1 divided by 4. That will give me the lower quartile, so that's the fourth value. Fourth value, first, second, third, fourth, is 14. Okay, lower quartile is 14. See, I've put that there. And then the upper quartile, well, the median is halfway, and the lower quartile is a quarter of the way. Add them together. The 8th value, add the 4th value, gives me the 12th value, and the 12th value is 30. So, and that's my upper quartile there. So that's the box plot. And then perhaps more importantly, the bit that I'm really interested in is comparing the distributions. So what I've done is here, I've put them next to each other, okay, to make it a little bit easier. And then I've made some statements. So the median waiting time is shorter at Greens than Roses. So what I'm saying is here, this value that I've just put in red looks to me like it's 21 seconds, the median time at Greens, but the median time at Roses is 21, 22, 23, 24, 25. So there's a 4-second difference in the median time. The interquartile range is wider for Greens than Roses. So you can see here that the gap between the lower quartile and the upper quartile is much bigger than it is here. So that's another valuable bit of information. Okay, so the interquartile range is wider for Greens, than showing the data is more spread. And then I've also said, I've just put a third one in, the maximum wait time at Greens is 55 seconds. And that's 11 seconds longer than the maximum wait time at Roses. And to think about it, if you're waiting to be served, you know, the quicker the time, the better, really, I suppose. You don't really want to wait around. Although 11 seconds, would you really be that bothered? I don't think I would. But that's what the information is telling us. So, really enjoyed today, actually. I think it's really relevant to use that information for screen time. I think that's a really relevant thing to be talking about. And those of you that spend a lot of time in front of a screen, there's a lot of evidence to suggest it affects sleep. So it's always good, I try to do this myself, is to not spend any time on a screen for an hour before I go to bed. I try to read something before I go to sleep rather than be in front of an actual screen. So that's something just to bear in mind, nothing to do with the maths, just something you might find interesting. Okay, lesson objectives today: compare the mean and range of two distributions, or median interquartile range as appropriate. Definitely done that today, looking at that pre and post lockdown screen time data. Interpret box plots to find median quartiles range and interquartile range and draw conclusions. Again, definitely done that. So we were looking, comparing box plots to make some sort of back up some statements. We did that in the last exam questionnaire as well, just the last thing we did. And then producing some box plots from raw data, and when given quartiles, median, and identifying the outliers. We haven't had a chance to talk about outliers today, which is a shame, and I really hope that we get to do that in a future session because it is important, but it just wasn't time in today's session. But I hope you enjoyed that one, and on that note, see you next week, Tuesday and Thursday, because there's one on Tuesday, one on Thursday every time. I'm really enjoying them. I hope you are too, and hopefully I'll see you for the next one. Take care, folks. Cheers. Bye-bye.